Here's a good question. Involves triangles. Bicycle race triangular course. Okay, so we're going to start here, go this way, back. And it says the legs of the race are 2.3, 5.9, and 6.2. Find the angle in between the starting leg and the finishing. So that's this angle here, to the nearest degree. Now, they don't tell us there's a 90-degree angle in there. Therefore, all of this stuff, our SOHCAHTOA and our Pythagoras, all that stuff gone, because there's no 90-degree. So my only other options then are the law of sines. So A over sine A equals B over sine B, or the law of cosines, which is something like this: C squared equals A squared plus B squared minus 2AB cos C. Okay, so I have to see what I have, and then I'll see if I can figure that out. Let's label this. Let's call this A, B, and C. So this side is side C, this is side A, and this is side B. So they want us to figure out that angle. Now, in order to use the law of sines, the easier of the two, I need to know a side and its corresponding angle. Here I know three sides, but I know no angles. Therefore, I'm going to have to use this guy right there. Now, since this is angle A, let me write the kind of formula we need for that. So if I am looking for A, this would be the formula. A squared equals B squared plus C squared minus 2BC cos A. And that's my unknown. That's what I'm going to go for. So you can either plug numbers in now and then solve for A, or you can solve the equation for A first and then plug numbers in. I'll maybe do it that way. So I need to isolate that term that has the unknown in it. So I need to get rid of this and this. So I'm going to subtract B squared and subtract C squared. I do that on the left side, and I'll get A squared minus B squared minus C squared equals minus 2BC cos A. Now I want to isolate this part, so I'm going to divide both sides by minus 2BC, divide by minus 2BC. So I'll have cos A equals A squared minus B squared minus C squared over minus 2BC. Okay, now let's plug some numbers in. Let me go down a bit more. Oh, I'm losing my decimals. Okay, so plug in numbers. Oh no, I've got to figure out what the numbers are. Okay, so I'll plug them in. So A is 5.9, so 5.9 squared, minus B is 6.2 squared, minus C is 2.3 squared, all over negative 2 times B is 6.2 times C, which is 2.3. Okay, is equal to cos A. Now, if you're using decimals, which I like to use, it's what you need to do now is solve for A. So I'm going to arc cos both sides. So I'll arc cos this side, and that'll cancel that out. But then I have to arc cos this side. Okay, so now I'm just going to plug all that in. And you can do this on a graphing calculator too. Okay, so let me make sure that this is in, degree mode. Uh-oh. Had a little dot there and it was messing with me. Okay, no, I'm in radians, so I need to switch to degrees. Okay, now let's type this stuff in. Why is it not letting me type? Could be stuff is messing it up. Okay, let me try something else here. Just a second. All right, so I need to go arc cos. So I hit function, arc cos, got it. 5.9 squared. Oh, now let me put a bracket to indicate I'm in my numerator. So I've got 5.9 squared minus 6.2, whoops, 0.2 squared minus 2.3 squared. Okay, and my top, and then I hit divide. Nice. Is it looking the same? Yep. And on the bottom here, I've got minus 2 times 6.2. Oh, I didn't get a point there. 0.2 bracket. Another bracket. 2.3. 2.3. 0.3 bracket. There we go. Now do I have everything written down right? 5.9 squared, 6.2 squared minus 2.3 squared, all over minus 2 times 6.2 times 2.3. And they give me an answer of 1.25. That doesn't seem right. Let's check our degree thing again. Oh, it switched to radians. Oh, there's degrees. There, so it's 71.77. So then A is equal to 77.77, but they said round it to the nearest degree, so I'd call it 78 degrees. All right, hopefully that helps you on that one. That's a tough question.